Okay, so here is a chapter 7 and 8 review worksheet. I want you to finish this review before you take the chapter 7 and 8 exam. Now it is due tonight by midnight, assuming you're watching this on the day I've assigned it. But you do want to finish this first. So I'm going to go through them relatively quickly. You can try the problems first on your own. This is a near replica of your chapter exam. So the problems that are done here in this review will look extremely similar to your exam. So that is why it's so important that you take the time to do this before doing your exam. Okay? So now a lot of this you're just going to want to refer back to your chapter 8 study guide because some of the formulas come from that. A few others might come from chapter 7 or even before that and back into last semester. So here it says find the interior angle sum for each polygon. Now there's only one problem here, so just this one. This one says round your answer to the nearest tenth if necessary. So here we have a regular 25-gon. That means the number of sides is 25. N is the number of sides. Now our formula for the interior angle sum is 180 times n minus 2. And we proved this during class, okay? Just noticed my pencil is a little bit smaller. All right, so 180 times, instead of n there, we know n is 25. So we're going to plug in 25 for n. So now we know it's 180 times 25 minus 2 is 23. Macy just sneezed in the background, but I'm glad you guys couldn't hear her. 180 times 23 is 4,140. All right, so 180 times, let me make sure I did that right. 180 times 23, yep, 4,140 degrees. So that is the sum of the interior angles. All right, so number 2, it says find the measure of one interior angle in each regular polygon. So they tell us the number of sides here. So I know the number of sides is 24. Okay. Now, to find the measure of one interior angle, you have to find the sum divided by the number of sides, the sum of the interior angles to be specific. So it's the 180 times n minus 2 because that's how we find the sum. Just like up above here, we use that formula to find our sum. And divide it by the number of sides. So whatever your number of sides is, that's what we're going to plug in for n in each of these spots. Okay? So here we're going to have 180 times n is 24, and then we have to subtract 2 for the sum. And then we're going to divide this by 24 because that's the number of sides. And the number of sides is equal to the number of angles inside. And since it's a regular polygon, we know that all the sides and all the angles are equal. Okay? So this would be 180, 24 minus 2 is 22, divided by 24. So I'm going to go and plug that all into my calculator. So I'm going to have 180, so I'm going to put this in parentheses, 180 times 22, like that. There we go. So then we can divide that whole thing by 24, the number of sides. So we get 165 degrees is the measure of each angle, and that's because the sum of those angles is 3,960, and since there's 24 of those angles that are all equal to each other, each angle is 165 degrees. So the measure of one interior angle of a 24-gon, that is a regular polygon, is, what was it, 165 degrees. I really miss having my notes split screen with my calculator. I'm the worst at remembering. So it's 165 degrees. Okay, find the area of each figure. Again, there's only one figure. So the area, if this is a, oops, it did not tell you. It should tell you this is a regular polygon. Okay, so this is a regular polygon. And it will be that on the test as well. Okay, so if it's regular, then that means all the sides are 2 inches long. And then if I were to split up the inside, so let's say this is my center, I can draw equivalent isosceles triangles if it's a regular polygon. And again, in this case, this is a regular polygon. Even though the directions did not specify it, it is a regular polygon. Okay, that's what I'm telling you. All right, so knowing this, we now see that we have 1, 2, 3, 4, 5, 6, 7 sides. So this is a heptagon. So this is a heptagon. Oops. Which has 7 sides. Okay, all this information is super important. So what we want to know, first of all, is that the area formula of a regular polygon, is equal to 1/2 times the apothem times the perimeter. Okay, so the apothem, I'm going to show you what that is. The apothem is the measure from the center of the polygon down to the midpoint of one of its sides. That would be our apothem. And we need to find that in order to solve for the rest of this area here. Now we also need to know the perimeter. Well, the perimeter is just adding up all of the outsides here. So what is the perimeter of this heptagon? Well, my perimeter is, since there are 7 sides and they're each 2 inches long, perimeter would be 7 times 2 inches, which is going to be 14 inches long here. So that's my perimeter, okay? So now so far I know A equals 1/2. I don't know my apothem, but I do know that my perimeter is 14. Okay, so we're going to go through finding the apothem. Find the apothem. So our first step is to calculate the central angle. Okay, so the central angle goes all the way across here. So it's at the top of each of the isosceles triangles here. So I had 7 triangles because there are 7 sides. Each of those central angles here are equal. So we have 360 degrees divided by 7. So 360 divided by the number of sides, because that's how many triangles are inside and how many central angles there are. In this case, my number of sides is 7. So if we do 360 divided by 7, we get about 51.428. So we're going to round it to 51.4. Okay, so we're going to say this is about 51.4 degrees. All right. Now the second step is to draw right triangle from half of isosceles triangles. Now it's an isosceles triangle because each of its sides here and here are equal. And that's because this is a regular polygon. Whoa, I'm flipping around my letters there. Triangle. So what I'm going to want here is just half of this triangle because I need a right triangle to find the apothem. Okay, so I'm going to draw that figure. So if I have that right triangle, and this is the apothem, okay, so it's just the same triangles up above. All right, I'm just making it a little bit bigger. Now, if I know that the entire central angle here is 51.4 degrees, what is half of that angle measurement? Well, 51.4 divided by 2, and that's because the entire angle here is 51.4 degrees. the entire central angle, but I'm just taking half of that. So if you were to divide that in your calculator, it's going to take the, whoops, answer divided by 2. Oh, we should take what we actually simplified it. So we got 51.2, divide that by 2, 25.6. Okay. So here, oh, I'm sorry, we did 51.4. That's my bad. So it'd be so helpful to have it split screen. 25.7. 51.4 divided by 2 is 25.7 degrees. All right, so that is how much this little angle is here, 25.7 degrees. Now, just like we reviewed in class, we can solve for the missing side of a right triangle using trigonometry. So just like we took half of the angle, we also need to take half of the side length to finish making the rest of this right triangle. So if the entire side length is 2, half of it is 1 inch. If the whole side length there is 2 inches, half of it is 1 inch. So now we have this triangle. And now the third step is to use SOHCAHTOA to find the apothem, which is our red side there. The apothem is the red side. Okay, so first we have to label, this is our focus angle up top here. That's our focus angle. Across from it is the 1 inch. And the side that touches both the angle and the right angle is your adjacent side. And we don't have anything here, right? So we don't have to worry about the hypotenuse here. So we have opposite and adjacent to work with here. Opposite and adjacent. That means we are going to use the tangent function. So we know tangent of some angle theta is equal to the opposite over adjacent ratio. So now we can set that up. So tangent of our angle here is 25.7 degrees. Okay. Equals our opposite side is the A, or the apothem, and our, oh, I'm sorry, I'm wrong. The opposite side is the 1 inch, it's the 1. The adjacent side goes on the bottom, is the apothem. Okay? So once you have this trig ratio set up, it's all about solving for the variable now. So what I like to do is cross multiply. You can also multiply both sides by a here if you wanted to get rid of the a in the bottom. But let's go and cross multiply. So 1 times 1 is 1. A times tangent of 25.7. And now in order to get the a by itself, we're going to divide both sides by tangent of 25.7 because that just equals 1. So it gets rid of it on the right side. And now all I'm left with on the right side is the apothem. So my apothem is going to equal approximately whatever 1 divided by the tangent of 25.7 is. So let's see what that is. 1 divided by the tangent 25.7. I get about 2.07. You can either leave it as that or we can round it to 2.1. It did mention rounding to the 10th place. I believe your test will be multiple choice, so if it's just a few digits off, you should be okay still. So we're going to round it to 2.1. Now we're still not done. What we just did was we solved for the apothem in order to let us find the area. So what we need to do is take that apothem and apply it up here into our formula. Okay, so again, this whole goal here was to find the apothem to plug it into our area formula. Okay, so it wasn't all for nothing. It's super important that we have the apothem. All right, so our apothem here is 2.1. So now you can plug all that into a calculator. You can rewrite 1/2 as 0.5 if you want. So now we have 1/2 times 2.1 times the perimeter 14. And I'll show you, even if you did 0.5, you're still going to get the same answer because 1/2 is equal to 0.5. As long as you type in the rest of the numbers right. Okay, so 14.7 is our area of this heptagon, this regular heptagon, regular 7-sided figure. So 14.7. So the area equals 14.7 inches squared for area. And this one will probably be the longest problem you encounter, so if you want to save it for last on your test, go for it. Skip this one and do all the others, and then come back to this problem here. Okay, so solve for x, each figure is a parallelogram. Well, this is on your, I believe it was the Chapter 7 study guide. So with the parallelogram, we know that the opposite angles are equal. Okay? We also know that like if C and D, those two add up to 180, and just like E and B would add up to 180, and D and B are equal. Okay? So if we know that angle D equals angle B, and we're asked to solve for x, we can set up an equation, 12x plus 10 equals 94. And now we can solve. So first I'm going to subtract 10 from both sides. And I'm going to go through these relatively quickly. You can always pause the video, make sure you are trying them out on your own first. I believe this is 7. Yeah. Okay. So that's just me checking my work. So I know x equals 7. 84 divided by 12 is 7. Okay. All right, so now this one we're given some sides. So again, we know that the opposite sides as well in a parallelogram are equal. Okay, so these two sides equal each other, and these two sides equal each other. So this one's really nice. Again, we know 15 is equal to x plus 9. This one's quick. Subtract 9 from both sides. 15 minus 9 is 6 equals x. Done. Okay. All right, here it says each figure is a trapezoid. Okay. So now this one's pretty nice. So it looks like here, let's go back. I'm going to show you what the trapezoid looks like on your Chapter 7. Oh, the properties of quadrilateral summary here. So there are the parallelograms up above. Here's the trapezoid. Okay. The one thing that we're looking at for this problem is that the diagonals are congruent, and then you can read everything else you need to know about the trapezoid as well. Okay. All right, so if I go back, oop, not that one. All right, so we are given BD, which is this one here, BD, and AC. And we just looked at our properties of quadrilaterals there, and we know that the diagonals are equal. Okay, we know that this is an isosceles triangle as well, and that's isosceles trapezoid, and that is whenever it has the two sides that are equal to each other. So since this is an isosceles trapezoid, then I know that the diagonals are congruent. Okay, if we didn't know that it was isosceles, then we wouldn't be able to state it. But since those two sides, A, B, and CD, are marked as the same mark, we know that those two sides are equal. So our focus here is on BD is 23 and is equal to our side AC, which is x plus 11. So here we just have to subtract 11 from both sides. 23 minus 11 is 12 equals x. And you're done. So really it's just knowing the properties of quadrilaterals and knowing how to apply them to solve the problem. Find the missing side of each triangle. So this one's only one triangle. This one's nice. This is not solved with SOHCAHTOA. We know at least two of the sides, and those happen to be the legs. And we know this fancy formula called the Pythagorean theorem, where a squared plus b squared equals c squared if we have a right triangle. Okay? So here you can say a and b are either of the side legs. So 12 squared plus 5 squared equals x squared. All right, c is always the hypotenuse. 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. Now we have to take the square root of x squared to get the x by itself. So I have to also take the square root of the left side. The square root of 169 is 13. So there's our answer. Okay. Here's another missing side. However, this time I'm not given two sides on the triangle, so I have to use trig for this one. So I'm given an angle measurement, so that shows me I can use trig, but I know that angle measurement. It has to be an angle measurement besides the 90-degree angle. So here I'm going to mark my focus angle, draw an arrow across. This is the opposite side. Okay, the side across from the right angle is the hypotenuse. And the side that touches the focus and the right angle is your adjacent side. So in this case here, we only know the opposite and the adjacent. So that means we're using the tangent ratio. So the tangent ratio tells us the tangent of some angle theta is equal to the opposite over adjacent. Okay? So in this case, our theta is our focus angle, 59 degrees. So tangent of 59 equals our opposite is 12, and our adjacent is x. And that's nice because we're solving for x. So that's why it has to be in our ratio. So here I'm going to go and cross multiply. 1 times 12 is 12. X times tangent of 59. We have to divide both sides by tangent of 59. X equals, so now we have to do 12 divided by the tangent of 59. And this is all big time review here. So this is about equal to 7.2 if we round it to the nearest tenth. So this is about equal to 7.2. And that's the missing side length there. Okay. All right, at West High School, 9.7% of students are on the marching band and also play a team sport. 38.3% of the students play a team sport. What is the conditional probability of being on the marching band given that you know the student plays a team sport? So conditional probability and given are the key words here. So they want to know what is the probability that a student is on the marching band given they play a sport. And now we want to put this into terms of a formula. So something like A given B is going to be equal to the probability of A and B, or both, over the probability of just the B, which in this case is the sport. Okay? So up here I see that says 9.7% of students are on the marching band and also play a team sport. So is that going to be the probability of them doing both or the probability of them just playing a sport? Well, this one says and play a team sport. So that's going to be the top probability here. Okay? Then it tells us that 38.3% of students play a team sport. So that's the probability a student is playing a sport. So the probability of both of them being on the band and playing a sport is 9.7%. and the probability of them playing a team sport is 38.3%. Okay, so now if you go ahead and divide this, 9.7. Okay, I lost connection for a bit, but all right, so if we have 9.7 over 38.3, and I go to divide that in Desmos, 9.7 divided by 38.3, you get 0.253 and so on. So to write that as a percentage, we want to multiply that by 100. 25.3% chance. Okay? So you have to look carefully at your answer choices. It's either going to be equal to 0.25, and I think it was 23, right? Or 32, got it. 32. Or it's about equal to, these should be about equal to 25.32%. I am having some technical difficulties here. All right, there we go. So you'll see one of those two answers as your choices for multiple choice on the test. Okay, so here's our last one. It is completing the square. So this is review. I'm going to go through it relatively quickly just for sake of time on the video. So I'm going to first add 23 to both sides. I have r squared plus 20r, and then this blank spot equals 23. So the first step is add c. Or I guess we should say move c, because if the c was a negative, or I'm sorry, if the c was a positive, then I would be subtracting it from both sides. So now what we want to do is add b over 2 squared to both sides. In this case, our b is the 20. So it's going to be 20 over 2 squared, which is 10 squared, which is 100. Again, I'm going through pretty fast because this is review. And most of you should know how to do this. If not, you definitely want to review completing the square. So now if I rewrite this, I have r squared plus 20r plus 100 equals 123. Okay, so now my next step is to rewrite as b over 2, as r plus b over 2 squared. And it's r this time instead of x because that's our variables r. So r plus our b was 20, so it's going to be r plus 10 squared is how you're going to rewrite this. This is us completing the square. Okay, now we have it written as a complete square. Now the very last step is to solve the equation, which means solve for r. So the last step is to solve. So the orange step, step 3, that's completing the square. That's perfect. We're done with completing the square. But now we need to solve it by taking the square root of both sides. So we're going to have r plus 10 equals plus or minus root 123. Now we need to subtract the 10 from both sides, and I always put it in front of the plus or minus. So I'm going to have r equals negative 10 plus or minus root 123. Now, this might be your answer choice right there. That might be it. However, if you need to further simplify, you want to split the plus or minus. So we're going to have r equals negative 10 plus root 123, or r equals negative 10 minus the square root of 123. And then you can plug these two into your calculator. So we have one of them is negative 10 plus the square root of 123, and the other one is negative 10 minus the square root of 123. So those would be your two roots for this parabola. So approximately 1.09 and negative 21.09. And then r is about equal to negative 21.09. Okay, so you're going to see it either like this or in decimal form. more likely than not. Okay? So hopefully this helped you. Make sure that you complete this before you do your exam. All right? Best of luck on the exam. You got this.